Now, I know what you're thinking. You're thinking, has Prezzo gone rogue and is he now doing product reviews? Well, yes and no, but let's take a look at what's in this box. Now this is an Ortur LM3 28 diode laser cutter engraver, and just for full disclosure, I didn't pay for it. It was sent to me by a company called Z-Banks or Z-Banks, not quite sure how you pronounce that, but they're a global brand marketing company that acts as sort of a broker to get products promoted via internet resources, i.e. Instagram, YouTube, Facebook, etc. Now I get regular contact from companies asking me to do product promotions. Happens about every week. Up until now, I respectfully declined on the basis that I didn't want to change my content and I didn't want to promote something unless I bought it with my own money. I figure that's how you keep your integrity when you're doing this. However, Z-Banks offered me a different brand of diode laser, not this one, and I thought it would be interesting and informative to do a video where I compared my 50 watt CO2 laser to one of the newer technology diode lasers. Now I pitched the idea and it was rejected by this other brand, but after some discussion with Z-Banks, they agreed to send me this Ortur laser and told me I was free to do the comparison. So that's what we're going to do today. Oh, great US style plug. Now, I'm a very passionate advocate for the use of laser cutter engravers in the home workshop. And I think they're an excellent tool, and if you use them as a tool and not just a printer, they can do an excellent job. Now, quite often what I see on YouTube is people who buy these machines and they end up using them just to burn patterns and designs and photographs into wood. Now, don't get me wrong, they're great for doing that, but they can do so much more. So let's take a look at a few examples of how you might use a laser cutter engraver and the sort of jobs that you can do with it. Now you can use a laser cutter engraving for making things like mock-ups and prototypes. They're an excellent rapid prototyping tool. You can use them for engraving on plastics and metal as long as those metals are prepared properly. You can make fabricated 3D parts from wood and plastic. You can make boxes and containers. You can apply decorative treatments to wood and glass. And you can cut difficult materials with speed and precision. So things like silicon rubber, which can sometimes be difficult to cut because of its springy nature, a laser cutter engraver can do that job easily. Also things like paper and cardboard, because once again of their nature they tend to be difficult if you're cutting with scissors or sharp knives. Laser cutter engraver does that easily. So in this video I want to do a side-by-side comparison of the two different laser technologies that you might be able to use in your home workshop. Now in this example I'm going to leave out a fiber laser because they are hideously expensive and certainly outside the price range that I can deal with. But what I want to do is to show you the strengths and weaknesses of both different technologies, and then you can make an informed decision about which is the correct one for you. But what I'm going to do first is have a crack at assembling the Ortur and then we'll get back to you. All of the parts supplied had a very attractive light blue anodized finish on the aluminium extrusions, and the assembly only required a handful of fasteners to hold everything together. The gantry was pre-assembled, preset, and just slide it onto the V-slot rails, and the frame turned out to be accurately squared and didn't require any tweaking or adjustment. And the only tricky part was getting the long timing belts seated on the pulleys at both ends. Tensioning the timing belts was achieved by a pair of jacking screws, and the belt profile slots into some machine grips on the underside of the gantry frame. The laser module itself is fully self-contained and just slides into some dovetail slots, and they also give you the Z height adjustment. The module contains 4 5.5 watt chips which couple together to give you a nominal 20 watt beam. The entire laser module is very light, it's just 555 grams, and this allows for better acceleration and deceleration during the engraving and cutting process. The only downside for me was the rather primitive method for managing the wiring loom and the blower tubing, but I'll talk more about that later. Well, it took about 90 minutes to get to this point, and it's sort of ready to plug in and ready to test. It went smoothly enough, but there were some peculiarities with it. For example, this part of the wiring loom was supplied, and I know where it goes. It fits into this socket at the back here. It says YRR, and that's the plug that goes in there. But I got no idea what it's for. It doesn't mention it in the instruction manual, and it doesn't seem to plug into any of these sockets here. I can't find any other place where it could go. And problem with the assembly manual is it's, I mean, it's comprehensive enough. You can work it out. It's got sort of look like 3D model renders for the assembly instructions, but the amount of text that you get to go with these photographs is fairly limited. And there are some parts that just aren't even mentioned. There are two sockets on the back here, no reference to that in the manual. One says Z, which I'm thinking is for a motorized Z drive, and one says C. Again, there doesn't seem to be anything that plugs into those, and it would be nice if it actually mentioned that in the manual. Now, the people at Ortur would do well to have a look at this booklet here. Now, this is the assembly instructions I got from my Prusa printer. Now, in my view, this is the gold standard. It's got excellent photographs, and they're actual photographs, so when you look at that, you can compare it to what you're seeing on your own machine, and it's quite clear whether you've done things correctly or not. And there's adequate instructions to go with the photographs. All the arrows are color-coded and they match up with the steps here. So I think Prusa have done an excellent job with that assembly instruction booklet. Now, the other thing is that the laser module comes with its own separate booklet. Again, it's a bit flimsy, and it's written in several languages, so you get about 2 pages to work out how it all goes. It took me a while to work out how to lock the laser module at its correct height. There is a screw, but in the instruction it doesn't tell you where it goes. You can work it out eventually. But like I say, it's doable, but it could be made more easy. Now, I'm going to plug this in and we'll try it out. Unfortunately, I didn't get an Australian 240 volt plug with it. I had to go and find one. And the air pump that goes with this was supplied as a US 110 volt pump. So I'm going to have to run that with a step down transformer. I've got one, but it's a bit annoying to have to lug that out every time you go to use it. So that's why I haven't plugged in the end of this tubing here. Now, you don't need the air to make the machine run. It's sort of a useful accessory. It sort of blows the smoke and any debris out of any engraving or cutting that you're doing, but it's not absolutely essential. Alright, there is an e-stop that's currently off, and there is a key switch here, which is probably a good idea if you've got children around. You can lock it out when you're not using it. So I'll enable the machine and we'll turn the switch to on. Alright, now lights up, but there is a boot switch on the back of this section here, so I'll just hit the boot switch. Now we got nothing. Well, here we are, half an hour later. I've got it to run. What I was doing wrong was I was only pressing that power button momentarily, thinking that would start it. You've actually got to hold that down for 1.5 seconds. Now, to be fair, that's in the manual. There's a page here which lists all the conditions and the warning lights and what it means, and I just didn't read it. Stupid me. I thought you just press that and it would start. Now, it started to home in X, and then it tried to home in Y, and it was just trying to, but it wasn't happening. Now, I figured it was something that I hadn't plugged in correctly. However, it turned out that when I was putting the zip ties on the main cable here, I'd accidentally looped one of the zip ties around the timing belt. Now, the timing belt is directly underneath this extrusion here. Put the zip tie through, and you can't really tell where it's going unless you tip it upside down and look. But it just stalled the drive motor, and that's why I wouldn't home. So I fixed that, and I've got it running. Now, in the manual, there is a QR code. So down here, if you scan the QR code for Android, you can download the app. So I did that to my phone, but it needs to connect by Wi-Fi, and I don't really have reliable Wi-Fi here in the garage. So I've got Lightburn running on a laptop, and I've connected it up to the machine, and I can run it now from the laptop. So let's start it up, and I'll just show you what happens when it homes. Now, it doesn't have limit switches or homing switches. It just runs into these socket head cap screws here, and that must be what tells it that it's actually reached the limit, the actual origin. So we'll boot this up. Alright, so it's homing now. Alright, so we've got a green status light there now. I've actually already connected to the laptop, so I can run a file. I'm going to set something up and we'll actually run an engraving file, and maybe then we'll do a cut file. but I haven't got the air pump hooked up to this yet, so I want to do that before we go any further. I've got this air pump hooked up now. It's on its own little wobbly feet here because it is a diaphragm pump and the diaphragm oscillates backwards and forwards. Now it has its own electrical speed regulator here, but it also has an air regulator in the line. Now the unit that was supplied is 110 volts and we've got 240 volts here, so I'm running this from a set down transformer. Now it's not really noisy, I'll just switch it on, and with the speed regulator you can turn it right up or you can throttle it right back. Now it doesn't supply a lot of air, it's probably enough just to blow away smoke and debris from the cutting area. But I'm going to hook up a file now and I'm going to run that on some wood. We'll do some engraving. Now Ortur does supply this data chart and it shows you all of the common materials that the machine can engrave and cut, and then it lists the speed and power settings for each of the laser modules. So the one that we're using today is the 20 watt module. The material I'm going to engrave is this wood, and I've chosen pine. Now it doesn't actually list this particular species, but it's about the same density as pine, and it says that we need a speed of 20,000 millimeters per minute and we need power set to 100. Now these are just a guide. I actually tried it out in those settings and I thought it was burning too deep, so I cut that back a bit. But let's set this up now and we'll run the file, and I won't show you the whole thing, we'll just do the start and finish and then we'll see what it looks like when it's done. Now I've just used frame in Lightburn. What that does, it runs the laser module around the perimeter of the design that you want to engrave or cut, and then you can position your stock under what you've chosen as your starting point. So I've chosen the bottom left hand corner, and from there we can run the file. Now another thing that I think could be improved here is that seeing through that red window is really difficult. The laser lens is directly behind that and it's offset toward one side, sort of over toward the left, and looking through from the front to the back it's also offset toward the front. So it's very hard to see where the initial burn point is going to be. Now I think that they could improve that by putting a data mark on the window, and around the side there's no red lens on this side here, so it's very hard to see through that to work out where your starting point needs to be. Another improvement would be to put a red dot laser pointer directly down through the lens so you can see where your start point is going to be. Well, who's that attractive looking gentleman? Now after you sand that off, you start to see the contrast between the highlight areas and the back surface which has been engraved. The engraving there is quite deep. Now I used a speed of 40,000 millimeters per minute and a power setting of 70%, and that's given that really good depth to the engraved area. Okay, so what we'll do now is we're going to try cutting some material, but I'm going to use felt just to give you an idea of what you can do with unusual materials. Okay, this material here is 3mm thick felt, and it's really good for making things like soft seals and washers and that sort of thing. And when you go to set the Z height on this machine, there's a little drop down depth gauge which you slide into position, and then this knob on the side here allows you to raise and lower the complete laser module. So you just drop it down until the depth gauge is sitting on the material, and then you can tighten up that little screw there. Now it's a bit awkward, it's sort of quite loose and wobbly when you loosen that off, so sometimes when you go to tighten it does actually move the lens of the laser module relative to the work, but it's not super critical, so it should be alright. Okay, let's try this. I'm going to run the air supply again for this because it does create a bit of smoke. Okay, now I was running that at 200 millimeters per minute and 100% power, and you see that it's cut that really cleanly. Pieces just fall out quite easily. So like I said, if you're wanting to make soft seals for projects, this is an excellent way of doing it. And you know, this will equally work on stuff like natural cloths like cotton and canvas and so on. So yeah, that's great. Okay, now we're going to go in next door. I'm going to look at my CO2 laser, and then we're going to talk about the strengths and weaknesses of both these technologies. Now this is my CO2 laser. Now I purchased this machine second-hand back in 2013. Now I paid around $250 for it, including the air pump, the water chiller, and a rotary axis that I've never used. However, it was a non-working wreck when I got it. It was supplied by an Australian vendor as a warranty replacement for a machine that we'd purchased prior to that. And it's probably the worst example of a poor quality Chinese 50-watt CO2 laser that you'd ever see. Now I had to do a lot of work to this to get it up and running and make it usable, but it's been reliable, and after spending about another $600 for upgrades and new parts, it is a working machine. Just lifted up the back cover of the machine. You can see the tube there. It's 850 millimeters long, it's 50 millimeters in diameter, and that tells you that it's a 50-watt tube. Now you'll sometimes see these sold as 55-watt tubes, but you should never run them at their full rated power. It will shorten the life of that tube considerably if you do that. Now this is the original tube, it's still performing well, and I only ever run this at about 90% of its full rated power. Oh, and by the way, never touch that part there. That's the high tension line from the power supply, and that will give you a real kick in the pants if you touch that while it's running. So let's take a look at 8 different things that you might need to consider before you make a decision about which type of laser cutter engraver suits you best. So these are price, physical size, weight, working area, Z height, noise, software, and safety. So in terms of price, a named brand of similar capacity to my 50-watt laser is available on eBay for about $2,900 Australian, including shipping. Now there are cheaper and no-name brands available on eBay, but in some respects you get what you pay for, and you should consider getting one from a retailer or a vendor that has some backup and support. Now the LM3 can be purchased direct from Ortur for around $1,200 US or about $1,800 Australian. Now in terms of physical size, most 50-watt CO2 lasers are large and heavy. You really do need a mobile base, although some come with casters built in. Now this VVOR unit is 970 by 670 by 650 millimeters tall, or roughly 38 inches by 26 by 25 inches. However, at only 25 inches tall, you would still need to raise it up onto some sort of frame. You also need space for the air pump and some sort of water cooling system. Now the Ortur unit is much more compact at about 600 by 650 by about 150 high, and that's about 24 inches by 26 inches by 6 inches. Now in terms of weight, CO2 lasers are heavy, so a 50-watt machine is between 50 and 75 kilos or 110 to 165 pounds, and that's just for the machine. You also need to factor in the accessories that go with that. Now the Ortur, by comparison, is very light at just 4.5 kilos or 10 pounds. You could easily just hang it on the wall when it wasn't being used, and it's quite portable, so you put it in the boot of your car or take it on the bus if you needed to. With regard to the working area, my CO2 laser has a maximum of 400 in X and 300 in Y, or roughly 16 inches by 12, but some more modern units are 500 by 300 or 20 inches by 12 inches. Now the 20-watt Ortur has a maximum cutting area of 400 millimeters in X and 380 millimeters in Y, or roughly 16 inches square. Now you can purchase a longer set of these side rails which extend the cutting area to a capacity of 850 millimeters in this direction, or roughly 28.5 inches by 16 inches. Now in terms of Z height, my CO2 laser has a motor-driven Z axis that can be adjusted in the software or on the keypad. I can lower the table by up to 200 millimeters or roughly 8 inches. This allows you to work on bulky parts and still focus the beam on the top surface of the part. Now the Ortur unit has a maximum cutting height as shipped of around 25 millimeters or 1 inch, although you can just raise the feet up off the bench using blocks of wood, 1, 2, 3 blocks, or you could fabricate your own leg extensions using the laser itself. Now Ortur also sell a kit of foldable feet which increase the Z height to around about 100 millimeters or 4 inches. And what about noise? Now most CO2 lasers with glass tubes are noisy. There is a built-in fan for extracting smoke and fumes. The water chiller and the air pump are also noisy, and the stepper motors all contribute to the overall noise level. Even when idle, the machine is still annoyingly noisy. Now by contrast, the Ortur laser is almost silent when idle, and even with the air pump running, it's still only moderately noisy. However, when it's actually cutting or engraving, the air cooling in the diode unit is still a bit intrusive. Now, what about software? Now, most CO2 lasers will ship with some sort of Windows-based vector drawing and machine control software. Most are pretty average at best, but if you purchase a machine with an open source driver, you can upgrade to Lightburn. Now, initially the drivers for my AWC 608 digital signal processor were not compatible with Lightburn, but recently that support was added, and I was able to use Lightburn to run this machine. Now, Lightburn's not free, but there is a trial version and the yearly subscription is reasonable. There's also a lot of community support for Lightburn. Now, Ortur have both an iOS and an Android app for controlling the LM3. Now, you do need to be able to access Wi-Fi for it to be functional though. They also ship a Windows-based interface for a PC, but Lightburn's probably the better choice. Now, in Lightburn, the setup for the Ortur was quick and easy and was pretty much automated. Alright, finally, the big ticket item, safety. Now, CO2 lasers are inherently more dangerous than diode lasers. The unfocused beam is reflected by mirrors inside the machine, and any accidental contact with that invisible beam will cause serious burns. Now, most machines will have an interlock switch on the lid to disable the trigger voltage to the laser tube, but this is not always 100% reliable. Ask me how I know. The high voltage required to trigger the laser is also a hazard, and any accidental contact with the high tension trigger wire will cause a serious electric shock. Now, diode lasers are a different class altogether. The laser beam aims straight down toward the work area, and the beam is visible in the blue spectrum. The distance between the lens and the work is very short, and it can be covered by a red filter shroud. It's a good idea to wear the supplied tinted safety glasses though. That's as far as I want to go in the comparison between these two different machine technologies. Now, you'll notice that I'm not discussing the differences between cutting and engraving on the two different lasers, and that's because it's a bit irrelevant really. The CO2 laser is a maximum of 50 watts, this one here maximum 22, and unfortunately you just can't cheat physics, and you're never going to get the same performance in terms of cutting. Now, in engraving you can get similar results from both machines. Now, having said that, this machine will not engrave or cut clear acrylic or glass, and my CO2 laser will not mark on any metal at all unless you prepare it with some sort of coating first. So in summing up, would I recommend this machine? Well, in my view, it's a good entry-level price point for laser cutting and engraving in the home workshop. And if you manage your expectations and you realize that it's never going to outperform that big, heavy, expensive CO2 laser, it is a good starting point. Now, in summary, am I going to give up my CO2 laser anytime soon? Well, no, absolutely not. But the thing I like about this machine is that it is lightweight and portable. So with this and a laptop computer and a location that had a PowerPoint, you could do laser cutting and engraving jobs off-site. And this will also serve as a backup for my CO2 laser, so if it ever goes down or needs maintenance, I've got something else I can use. Now, you may also think I'm not impressed with the performance of the machine, but that's not true. Let me show you a couple of jobs here in close-up. So this first job here is a piece of 12mm thick pine, and according to the specs you can cut this material with 2 passes. So I set it up using the parameters that came with the sheet, and it did indeed almost cut through the other side. You can just see the kerf starting to penetrate there. And that was surprising because my 40-watt laser can also do this, but not much better than what we're seeing here now, and not much quicker either. So that was surprising. Now, I was also able to etch this anodized aluminium, and it came out really crisp and with good definition. And this is a sample that actually came with the machine. There were several of these. So that was impressive. Now finally, I was able to get this to etch on stainless steel. Now it's more like a heat stain, and although the definition is good, the contrast is fairly low. But this is something that I definitely cannot do on my CO2 laser. And it's all to do with the wavelength of light that each laser produces. But again, with a bit of tweaking, I think we could probably get a better result. Now with that, I think I'll finish up. If you check the link in the description of this video, it will take you to the Spanx website, and there are some deals and offers there. But just to be clear, I'm getting no kickbacks or commissions on this video. I deliberately set it up that way so you could be sure you were getting an unbiased opinion about my thoughts on this machine. Now check with me for the next video, which will be the diesel furnace burner build, and that'll be out in about a week, and I'll be able to wrap up that build in that video. So for now, it's Prezzo signing out, and buy a laser. You know you want one.